Perfect. So I'm going to concentrate just for the next 10 minutes or so on the rare earth elements, which is something that we've been working on for a good few years through the EU Rare, SOS Rare and High-Tech CARB projects. That's better. The rare earth elements, what are they? Why do they matter? Most of us have probably heard quite a lot about them. And if we look at the European Commission's criticality assessment, this is the 2017 one, and I really don't expect you to read all of the names of the metals there. But as Eleanor was just saying, most criticality assessments plot economic importance against supply risk. And for the rare earth elements, what we see, and what we've seen in every criticality assessment done in the last 10 years, is that they plot right at the top. They're seen as economically important and having a high supply risk. And the rare earth elements, they're a group of 15 elements, and then they're used for a whole range of uses: catalysts, polishing. But the most important uses are in the permanent magnets that are used in many types of wind turbines and in electric cars, in driving the motors. And of those 15 rare earth elements, the most important ones are neodymium, praseodymium, and dysprosium, often talked about as the critical rare earths, because they're used in these applications that are expected to grow, cause growing demand over the coming years. So why are we interested in the rare earth elements? Well, many of you will know that it goes back to around 2010, and this diagram illustrates the issue really well. This diagram is from Largescale in Asian Metal, thanks to our collaborator David Merriman. And it shows the range in rare earth element prices over the last 20 years or so. And it shows the spike in 2010, which was down to the fact that the Chinese export quotas were tightened significantly in 2010. And that really pushed up that price spike. Since then, rare earth prices have recovered as it was recognized that really the export quotas weren't so much of an issue. But you can see that they've bumped along at a slightly higher level with peaks and troughs up till 2020. And that price spike has driven really a lot of exploration for the rare earth elements. It's driven a lot of research. It's driven a lot of interest in these elements as critical metals that we really need. And then we're expecting to see demand growing. Now, why has that interest happened? Well, really, it's because if you go back to 2010, you can see that almost all the production of the rare earth elements came from China. And that's why the Chinese export quotas were such an issue. And in terms of environmental and social governance, I guess there were concerns about China at that time. There were quite a lot of news stories about environmental impact, about illegal mining, that kind of thing. And there were also concerns about security of supply. And simply, if China decided to tighten its grip on rare earth elements, could the world get the rare earth elements it needed? Well, since 2010, things have changed significantly. And if you look at the latest USGS figures, which are the figures for 2019, what you now see is that in terms of production, so in terms of actual mining of the raw materials, China is only producing around 2/3 of the world's rare earth elements, with significant production in the USA, Myanmar and Australia, and a whole host of other countries producing smaller amounts. So superficially, that seems great. The security of supply issue to some extent has been solved. Let's just take a look at those different sources for the rare earth elements and have a think about whether it's made a significant difference in terms of responsible raw materials. So I'm a geologist, as Sarah said, and so I'm going to bring in some geology and just mention the different types of primary rare earth resources. So you can group them into high temperature deposits formed by magmatic and hydrothermal processes, basically in the roots of ancient volcanoes, and then low temperature deposits formed by processes that occur at the Earth's surface, like erosion and weathering. And a lot of the exploration over the last 10 years has been in alkaline igneous rocks and carbonatites, which are known to be the highest grade sources of the rare earth elements and which occur in every continent and indeed in most countries across the world. And also a small amount of other types of deposits like vein and skarn deposits. And then we have the mineral sands, the laterites and the iron adsorption clays. Iron adsorption clays, particularly in South China, represent the source of much of the world's heavy rare earth elements. And also the possibility of producing rare earths as byproducts from aluminium production from bauxites, which we just heard about from Eleanor, and also byproducts of phosphate production from phosphorites. And Francis Wall, who led two of our major recent projects, including SOS Rare, published a paper on responsible sourcing of the rare earth elements in Elements, the journal, in 2017, which I highly recommend looking at. And it included this nice table, which shows that the high temperature deposits, the hard rock deposits, like your alkaline rocks and carbonatites, are, they may be quite high grade, you don't have big footprints for the mines, but there's a lot of issues around the energy that has to be used to mine and crush and grind those rocks, then to process them, the complex minerals, the amount of chemicals you have to use. Environmentally, there's potentially an awful lot of issues around energy use and chemical use. By contrast, if you look at some of the lower temperature deposits, which are often looser material at the Earth's surface, you might need to move a lot of material. You might need to have a large footprint for your mine, but you may not need an awful lot of energy to do the mining and to do the crushing and grinding. And some of your processing might be quite simple. The amount of chemicals needed might be quite variable. And so that gives you the greens that you can see for iron absorption clays and mineral sands. One of the problems that you will notice for mineral sands is that they are often associated with high radioactivity because the rare earths are in monazite, which typically also hosts a lot of thorium. And then the bottom two rows show that if you can produce rare earths as byproducts, that has a lot of advantages because often the rare earths would otherwise be in the mining waste and you can produce from those. So how have the different rare earth sources that we use changed over the last 10 years or so? Back in 2010, the main sources were, of course, in China, the large Bayan-Obo carbonatite mine, and also iron adsorption clays, as I mentioned. Very small amounts were produced in Asia, in various countries, India, Thailand, and others, from mineral sands and also alkaline rocks in Russia. As we saw, the price spike drove a lot of exploration, and it drove the opening or reopening of two major mines, Mount Weld in Australia and Mountain Pass in the USA. Mount Weld has continued operating ever since. Mountain Pass has been up and down, stopping mining in 2015, restarting in 2018. In China, mining has expanded. They're mining rare earths from several different deposits. And through the last 10 years, but particularly we saw this around 2015, they have tightened up their environmental regulations and their governance for rare earth deposit mining. So that actually now, when you look at mining in China, some of the issues that concern people in 2010 have been largely dealt with. And they're making real efforts to reduce illegal rare earth element mining. However, what we see in the USGS figures is that from 2018, we start seeing production of iron adsorption clays for rare earths in Myanmar. And in terms of environmental and social governance, that is potentially a real issue. And those raw materials are taken into China for processing. And in 2020, as per that diagram I just showed, we've got rare earth mining in many countries, in iron adsorption clay and mineral sand deposits, and in most cases, those ores are taken to China for processing. And here's a map that is nothing like as advanced as what Eleanor showed, but just showing the countries where we have rare earth production. This is the 2018 map. And if I just pop on some arrows that show where rare earth raw materials from those deposits go for processing, you can see the answer is almost all China. In other words, what we see is that we're producing rare earth elements in mines across the world. But most of the time, the raw materials are going to China for the processing. And so China really does control that value chain. And so China is very much in control of everything that's happening in the value chain. But much of its production and its processing is now actually really quite well regulated. They've made a lot of changes in China in their rare earth industry over the last 10 years. And maybe we shouldn't have so much concern anymore about environmental and social governance of the rare earth industry in China. But perhaps what we should be considering, and we hadn't thought of this, I don't think, in 2010, is that production may have expanded to a range of different countries. But now we've got many smaller producers mining rare earths in iron adsorption clay deposits and mineral sands across the world. How is that governed? There's relatively little information out there. And what happens to the thorium if the rare earths are being mined in monazite? Again, there's relatively little information out there. And rare earths are being produced as a byproduct, for example, of titanium in mineral sands. But in terms of the big phosphate and aluminium production, although that seems like a really good potential for producing rare earths, there's been a lot of research, but the technological and economic issues are such that at the moment there's no significant production of rare earths through that route. And finally, of course, recycling still remains limited. So the overall kind of sum up of this is that since 2010, rare earth production across the world has broadened significantly. China no longer controls mining. So we've achieved the diversification of supply that perhaps we were looking for in 2010. But has that been a benefit or not? It's an interesting question. And as we've seen today, press releases from the World Bank on mineral production soaring as demand for clean energy increases, and from The Guardian talking about green energy firms delivering multi-billion-pound wind farms, then we can see that these questions are going to continue to be really important. And I'm just going to plug, if you'd like to learn more, you can go to our High-Tech Outcarves massive online open course in FutureLearn on technology metals for a green future. Thanks very much.
Brilliant. Thank you very, very much, Kathryn. And yes, you can hear that wonderful applause ringing in your ears at the moment. And if we may, Rose and I will also provide the link to that resource that you just cited now on the website as well. So if that's okay with you. Thanks, Kathryn. Yeah. Also as well, by the way, if anybody's not aware, the British Geological Survey also has a huge array of other really good online resources as well. So whilst we're just letting those questions come through, Kathryn, so what you really clearly showed in your short presentation just now was that diversification of the actual digging or the scraping of the rare earth elements out of the ground, but all of it seems to still go to China. So if we moved that, so back in 2010, when 97% of the world's rare earth elements came from China, what percentage of the world's rare earth elements are processed in China today? Do you know?
I can't answer that exactly, but I know that Mount Weld in Australia, the mining there, all of the rare earths are processed in Malaysia at the LAMP facility. So that's a bit of vertical integration going on there. Otherwise, there's small amounts of processing. For example, Brazil and Russia, I think, are doing domestic processing. But most other rare earths go to China for processing. And so I'm going to say, including those from the USA, and so I'm going to say that it's between 85 and 90% of all the world's rare earth elements are processed in China. So China absolutely still controls that value chain.
And why is that, Kathryn? I mean, so what is it with regards to this processing that nobody else can do?
I think technologically, there's obviously quite complex beneficiation and processing because you've got 15 rare earth elements in every mineral. And most of the time, what you want is the neodymium. So to go through extracting the rare earth elements as a group from those minerals and then getting them separated so you can get the neodymium out is some fairly complex chemistry. And there's been loads of research across Europe and across, I'm sure, across the USA, of course. But in terms of scaling those processes up to industrial scale at an efficient and effective way, China has real control.
So is that something, I mean, with regards to things like the European Critical Materials Initiative and industrialization strategy and lots of R&D money, so that research and development money going into how do you pull apart all of those elements that all fit in that funny box that sits down the bottom of the periodic table, which is there because they're all so similar. Do we see any future with regards to trying to pull some of that processing out of China to get that diversification, or do we think this is just how it is at the moment?
This is a really interesting question, and I see that people like Vito Carrera are online who have been really involved in some of this. So I was working on the EU Rare project, and there was a terrific amount of research and up to pilot scale on beneficiation and processing actually for European rare earth deposits in that project. And of course, we did have rare earth processing in both in France and in Estonia in the past, and those processing plants are now more dealing with recycling and not really, as far as I understand it anyway, unless there's anyone online who knows more, not really with primary rare earths. So we have had that technology, but for many companies, it's much more efficient, effective and economic to do that kind of processing in China. And so in fact, much of that has moved. So we have a lot of expertise in Europe, but to actually get the next step to progress it to actually happening again in Europe requires not just technical expertise, but a lot of economic interventions as well.
Fantastic, thanks, Kathryn. And there's another question, apologies, that's just come through from Mikhail, and what he's asking is around, so I guess if we phrase this with regards to all of the thorium, for example, that perhaps is something that we're concerned about whenever we're mining something like mineral sands, for example, so the iron absorption. So if you're talking about a large company, obviously there's lots of compliance, there's lots of rules and regulations generally that those companies are beholden to, either on an international scale or perhaps on a company compliance scale, as it were. How can we make sure that those smaller mines, for example, are adhering to those requirements, and I think, as you were alluding to, aren't actually causing more of an environmental problem, especially with regards to things that may be radioactive, for example?
Yeah, it's a really interesting question, and which I can honestly say that I don't know the answer to. I feel this is something there's not a lot of easily available information in the public sphere, and it's not something that I've looked into in huge amounts of detail. But what we do know is that if you are mining a mineral sand for, let's say, ilmenite to produce titanium, you're going to have most of the time monazite associated with that mineral sand, and so you're going to end up storing your monazite somewhere, but as a naturally occurring radioactive material. So what's happening now is that in many cases that monazite is being separated, sent to China for processing to extract the rare earths. Fantastic. And then you probably have thorium as a byproduct, which has to be stockpiled, and then it's probably no longer in a naturally occurring mineral, it's being separated. And of course, if there's a use for that thorium, fantastic, obviously. But what I don't know is what happens at that stage in the supply chain and what's happening to that thorium. I genuinely don't know. I'd be really interested if anyone does. I'd be interested to hear.
I think just building on this, and I know, Kathryn, you said, yep, we'll be interested to hear, but maybe as well what Mikhail is getting at is, so yesterday we had a fantastic talk from Sarah Caven where she was talking about the artisanal, small scale through into the large scale mining. And something perhaps that's really interesting about mineral sands is actually a lot of the comminution, so the crushing of the rock has already been done. So therefore, if you are a artisanal or small scale miner, the sorting of that rock's really easy, relatively speaking. Do you know of any artisanal or small scale mining operations where people are separating out the mineral sands and so therefore potentially leaving themselves with piles of radioactive minerals, or is it something that's more being done by the large scale mining companies because in order to make any money from it, you have to be able to send your product to China?
It's a really interesting question, and I would say in terms of mineral sands, from what I know, we're talking medium to large scale companies. You know, there's dredging, that kind of thing. It will be mechanized. It may not be huge. Whether there's any sorting going on site or not, I don't know. The only mineral sands producers that I've visited personally haven't actually been separating out the monazite. It's just gone into the waste piles. The iron absorption clays, well, that's something that does happen on a real artisanal scale. And often that is a case of using large scale chemicals, often in situ. So you pour your chemicals in at the top of the hill, let them leach out the rare earths on their way down and collect them in ponds at the bottom of the hill. And in China, that's being increasingly regulated. But in Myanmar, I don't know, who can say, I would think.
So maybe, I guess, then there is a suspicion that some of these environmental problems, whilst China's been doing a fantastic job on actually getting to grips with some of those environmental problems. Maybe some of it's being pushed sideways slightly.
Yes, I think that does seem to be to some extent the case. But like I say, in terms of public information out there, I think one of the issues is that some of these concerns are being moved to countries that perhaps don't have such strong governance of their mining and mineral sector. I've been to Myanmar and talked to people about this, so I am really aware that this is an area where there's significant concern. Brilliant.
Well, thank you very, very much for that fantastic talk, Kathryn, and hope you have a lovely rest of your day. Round of applause. Thank you very much.